Okay, I think I'm live. Just a second. Let me recheck if I'm live or not. I think I'm live. Let me share my screen with you. Okay, my screen is completely visible. Let me read the problem statement. You're given an integer nums and a positive integer k. A subsequent sub of nums with length x is called valid if it satisfies substring of 0 plus 1 mod k. Acha. Okay, okay. So it is same like yesterday's problem. Just in place of 2, we have k. Okay. So in place of 2, we had two possibilities of remainders, either 0, either 1. In this, we will have multiple possibilities of remainders. Like for 5, we will have uh, 0, 1, 2, 3, 4. Okay, we will have this much possibilities. For another number, we will have n minus 1 possibilities. So any k value, we will have k minus 1 possible remainders. Great. Okay. Okay. So great. So suppose a plus, like the question is a plus b mod k is equal to b plus c mod k, right? If we'll cancel out b, we will have a mod k is equal to c mod k, which is going to be like we are going to have maximum of two remainders. Like either all the remainders are going to be equal, like r1, r2, r3, like r remainders of the consecutive elements, all the remainders are going to be equal, or we will have maximum of two remainders alternating, like r1, r2, r1, r2, r1, r2. I think it's clear to everyone. Like alternating remainders for making the subsequence longest, we will have maximum of two of them. So this is come like similar of a DP problem, which we are going to keep a DP array of k cross k. Okay, and we'll keep the remainders, and we will evaluate on the basis of that, on the basis of all the previous remainders. One second. Okay. Great. Okay, let me just write the code without wasting any time. Let me initialize a vector. Let's write dp of k size k comma 0. Okay, great. I made a 2D vector. Now what? I will have to, for each and every element in the nums, I'll have to check all the previous remainders, right? So for auto x of nums, first of all, for all the previous remainders, okay, remainder is equal to 0 to remainder is smaller than k, remainder plus plus. Okay, now what I have to do for every previous element, dp of uh, remainder x mod k is equal to nothing but dp of x mod k, mm, remainder plus 1. Okay, current is going to be previous plus 1. Okay, this way we are going to calculate all the possible remainders. Okay, great. Now we have to find just the maximum of all of them. And answer is equal to 0. So for and I is equal to 0, I is smaller than dp dot size I plus plus j is equal to age smaller than dp of size k. Answer is equal to max of answer comma dp of I and j. Great. Now what? Return answer. That's it. I think this is the right approach. Without doing this external loop, we can just get our answer from here itself. It's not a big deal, but no issues. Let's just submit this code and see if this code is working or not. Yeah, it is working completely fine. So what is going to be the time complexity? The time complexity is going to be I'm iterating through all the elements of nums, which is going to be like nums dot size n, let's suppose n cross k. Okay, and cross k and space complexity is going to be k square. Yeah, so I think this is one of the optimal approach that I can think of. The only thing that we have to keep it in mind about the remainder part, like how we are going to calculate the previous remainders and all. So I think it's a very naive and simple approach. Thank you so much for watching.